Did you know that promises in JavaScript are like a deal about future events? Here, we create a promise called myFirstPromise. It's a function that decides whether to fulfill or reject the promise based on a condition. In this case, the condition is true, so the promise is resolved with a success message. If the condition were false, it would be rejected. We handle these outcomes with then for a resolved promise, displaying the success message, and catch for an error, logging it to the console. Let's write our first promise to understand how it works. Here, we have a function, loadImage, which returns a promise. This promise tries to load an image from a URL. If the image loads successfully, the promise is resolved, and the image is displayed on the screen. But if there's an error, like the image can't be found, the promise is rejected, and we log an error message. By using then and catch, we can handle these two outcomes effectively, ensuring our code reacts correctly no matter what happens. Now, let's handle the results of our promise. In this example, we have a function getData that simulates fetching data asynchronously, taking 2 seconds. It returns a promise, which, after 2 seconds, resolves with a message, data received. We then use then to handle this success scenario, logging the received data. If there were an error, and our promise got rejected, the catch method would catch it, allowing us to handle errors gracefully by logging them. This way, we ensure our app remains robust and informative, regardless of the outcome. Handling errors is crucial when working with promises. Here, we have a function, fetchUserData, that attempts to retrieve user data. If a valid user ID is provided, the promise is resolved with user data. However, if the user ID is invalid, like in this example where we pass null, the promise is rejected with an error. We catch this using catch, which lets us handle the error gracefully. This is essential for maintaining a smooth user experience, as it allows us to display helpful error messages instead of letting the app crash. Did you know you can chain promises for sequential asynchronous tasks? Here, we have two functions, fetchUser and fetchUserPosts, each returning a promise. First, we call fetchUser with a user ID. Once it resolves, we use then to log the user data and then call fetchUserPosts with the same ID. The second then waits for fetchUserPosts to resolve and logs the posts data. If any promise in the chain fails, the catch at the end handles the error. This chaining keeps our code clean and easy to follow. Let's execute multiple promises in parallel. Here, we have two functions, fetchUser, which fetches user data, and fetchPosts, which gets posts data. Instead of waiting for each one sequentially, we use promise.all to run them at the same time. Promise.all takes an array of promises and returns a new promise. This new promise resolves when all the promises in the array resolve, giving us their results in the same order. If any promise fails, promise.all immediately rejects, and we catch the error with catch. This is efficient for handling multiple asynchronous tasks concurrently. Avoid nesting promises as it can lead to complex and hard-to-maintain code. Here's an example of what not to do. We first fetch a user's profile and then, inside the first, then, we fetch their settings. While it works, this nested approach makes the code harder to read and debug. It's like putting a box inside another box. To reach the inner contents, you have to open both. We should aim for a cleaner approach, like chaining promises, which we'll explore in the next part. This keeps our code more organized and understandable. Understanding error propagation in promise chains is key for robust code. In this example, we first validate a user with validateUser. If the username is invalid, the promise rejects. We then attempt to load user data with loadUserData, but only if the user validation succeeds. Here's the important part. If any promise in the chain fails, the error is caught by the single catch at the end. This means even if validateUser fails, loadUserData won't run, and we handle the error gracefully. It's a neat way to manage errors in sequential asynchronous operations. Finally, let's explore using finally in promises. Here, we have a function, processOrder, that simulates an order processing operation with a random success or failure. We handle success with then and failure with catch. But what about actions we need to perform regardless of the outcome? That's where finally comes in. After handling success or failure, finally runs, allowing us to execute cleanup operations or reset states. It's a powerful tool for ensuring our code tidies up after itself, no matter what happens in our promises. Did you know async, await, is a syntactic sugar for promises? It makes our asynchronous code look and behave like synchronous code. Here, we have two async functions: get user data and display user data. Get user data fetches user data using await, which pauses execution until the promise resolves. If the fetch fails, it throws an error. In display user data, we use try catch to handle these errors. This way, our code is cleaner and easier to understand, making asynchronous JavaScript much more manageable and elegant.